So to the proofs, first we want to show that phi is a homomorphism. Like we said, to show isomorphism, we have to show that it's a homomorphism, then we have to show that it's onto, and then we have to show that it's one-to-one as well. So I'm starting with homomorphism. This is the proof for homomorphism. Now to explain every single step. Firstly, you need to know this test for homomorphism. This is the test for homomorphism here. But I started by saying that if g raised power I and g raised power j are in G, then phi of g raised power I, g raised power j is equal to phi of g raised power I plus j. This is just law of indices. This times this is going to give us this raised power this plus this. Now, to show homomorphism, we need to prove that phi of g raised power I and g raised power j is equal to phi of g raised power I dot phi of g raised power j. That means we can, separate them. Now, to show the proof, how this proof works is that you are going to work on this, simplify this to get an answer, and then simplify the right hand side as well to get an answer. Then if the answers are the same, you have proven that this is equal to this. Now, how did we do that? Since from here, this first line, we know that phi of g raised power I, g raised power j is equal to phi of g raised power I plus j. By division algorithm, we can divide I plus j, which is the power, by n to give I plus j is equal to nq plus r, where 0 is less than or equal to r, less than or equal to n minus 1. That's from the degree of powers that we had. The powers went from 0, g raised power 0, g raised power 1, g raised power 2, all the way to g raised power n minus 1. So r is in between there. Now, since we already know that we are here, right? Phi of g raised power I plus 1 and I plus j rather, and we have proven and we have used division algorithm to let I plus j to be equal to nq plus r. We're going to have, substituting nq plus r for I plus j here, we're going to have this. So we have phi of g raised power nq plus r. Law of indices, I can separate that. This, which is going to give me phi of g raised power nq dot g raised power r. This is g raised power r, don't mind my handwriting. Then simplifying that further using law of indices, I'm going to have phi of g raised power n all raised power q dot g raised power r. Now this is exactly where you're going to start getting something interesting, because we know that g raised power n is equal to 1. How do we know that g raised power n is equal to 1? Because it is a cyclic group. So we're going from g raised power 0 all the way to g raised power n minus 1, right? So after n minus 1, the next term after n minus 1 is g raised power n. But because it's a cyclic group, g raised power n is going to start all over again. So g raised power n is going to be g is equal to g raised power 0, because the group has ended here. The next term is the identity, which is equal to 1. So in every cyclic group, whenever you are raising the power of the generator by the order, it has to give you the identity. That's how we know that g raised power n is equal to 1. So using that, I have phi of 1 raised power q dot g raised power r. I think you should understand how we got there. And this 1 raised power neq is still 1. So it is phi, and that's how we got phi of g raised power r. And since we know that phi of g is phi of g raised power I is equal to h raised power I, like we did in the previous page, we said that phi of gi is equal to hi. That's what we defined the map to be. So phi of g raised power r rather. I keep saying g. When I say gi, I mean g raised power I. So when I say gr, it means g raised power r. So phi of g raised power r is equal to h raised power r. Now we've simplified it to get this. Now I want to do the other side, which is this one. Phi of gi dot phi of g raised power j, phi of g raised power I dot phi of g raised power j is going to give us h raised power I dot h raised power j, just because of this, right? Then following the same sequence that we did for this one, we're going to have this, including the division algorithm that we used. So we have from phi of g raised power I dot phi of g raised power h gives us h raised power I dot h raised power j, which gives us h raised power I plus j, which then gives us what? h raised power nq plus r. Using law of indices, that's h raised power n raised power q dot r. And like I said, h is generator, so h raised power n is going to be 1. So 1 times h raised power r is going to give us h raised power r. Since our answer here is h raised power r and our answer here is h raised power r, we have shown that this is equal to this. Hence, we have proven that phi is a homomorphism.